Alright, hi Math 100. In this video, I'm going to talk about product quotients involving radicals. First thing I wanted to show you was this formula here. The nth root of BC equals the nth root of B times the nth root of C. So basically this is just saying if you have something multiplied, you can split up that one radical into two radicals keeping the same index. Right? So that is a rule. But one other thing you could do is this goes both ways. So you can split it up this way, but if you started with this, you can multiply. So if we have the same index, we can multiply the B and C together. Let me show you. Look at A here. Of course, we have multiplication here because we have parentheses right next to each other, as you can see. So basically what you can do here is you can, of course, multiply the 2 and the 3 together. So let me write that out. You can multiply the regular numbers together. But also you can multiply the radicals together because they have the same index. They are both square roots. So you can multiply the square root of 3 times the square root of 5 together. So what would you get? 2 times 3 is 6, and the square root of the times the square root of 5 is the square root of 15. Now always go back and look, make sure you can't simplify any further. You can't, because 15, there are no perfect squares in 15. So this is your answer. Alright, next we have 2 times the cube root of 6 times 5 times the cube root of 4. And I know those 3's or indexes seem very close to the 2 and the 5, but it's actually the index is 3 and it stands for the cube root of a number. So here you can multiply the 2 and the 5 together, which gives us 10, and you can multiply the cube root of 6 times the cube root of 4 together to get cube root of 24. Now always check your answer to make sure you cannot simplify any further. Do you think you can simplify 10 times the cube root of 24? Well, you actually can, because 24 contains a perfect cube 8. So 10 times the cube root of 8 times 3, you have to get the perfect cubes out. Cube root of 8 equals 2, so it's really 10 times 2 times the cube root of 3, which equals 20 times the cube root of 3. Alright, let's move on. For C, what we could do is, it's still multiplication, but notice we can just use the distributive property here. So this is a good way to do this problem. Cube root of 3, well, the square root of 3, the square root of 3 times the square root of 6 is, and we can multiply that, of course, because we have the same index, square root of 18 plus, what is the square root of 3 times the square root of 12? That gives us square root of 36. And let me just suggest that you try to work these problems out even before I solve the problem, or pause the video before I solve the problem, so you can see if you know what you're doing. Alright, now we're not done, because 18 contains 9, which is a perfect square, and also 36 just happens to be a perfect square. So you won't have a radical left here. You'll just have 6 here. Square root of 9 is 3, so you have 3 radical 2 plus 6. Now, do you think you can add the 3 and the 6 together? Is another good question. Actually, no, because we learned in a previous video that in order to add radicals, you need the same index and you need the same radicand. And notice that 6 doesn't have radical 2 attached, so you cannot add the 3 and the 6 together because they're not considered like terms. So the answer is 3 radical 2 plus 6. Alright, for D, let's go ahead and distribute again. Radical 6x times radical 8x is radical 48x squared plus radical 6x times radical 12xy is 72x squared y. Here, with 48 and x squared, we can break down because 16 times 3 is 48. 16 is a perfect square, but of course x squared can be broken down again. Also 72, you have 36 times 2. X squared is a perfect square, so we write it out like so. Always remember to put some space in front of your radicals. So square root of 16 is 4, so that goes out. 3 stays in. Square root of x squared is x, so you have 4x radical 3 for the first part, plus square root of 36 is 6. 2 stays under the radical. Square root of x squared is x. Y stays under the radical. So you have 4x times radical 3 plus 6x times radical 2y. That's the final answer for that one. We're going to distribute again. We have the cube root of 2 times 5 times the cube root of 4. So here, notice, just remember or recall your rules. You can only multiply a cube root times a cube root. So that 5 will stay on the outside times the cube root of 8, because 2 times 4 is 8, minus, multiplying now, cube root of 2 times 3 cube root of 16. That 3 will stay on the outside, but it will be cube root of whatever 2 times 16 is, which is 32. And obviously we can break this down further because 8 is a perfect cube. 5 times cube root of 8 is 2, so the radical completely goes away here. Minus 3 times the cube root of 8 is also in 32, so I need to break this down a little bit more, right? And I know that is 2. So what we have is a 10 minus 3 times 2 cube root of 4 because of that cube root of 8. That will give us 10 minus 6 times the cube root of 4. Now, another question. Can I subtract the 6 from the 10? Yes or no? Actually, no, you cannot. These are not like terms because that 6 is attached to a cube root of 4. The 10 is not attached to a cube root of 4. Therefore, they are not like, and we cannot subtract the 6 from the 10. Alright, F. So what we have is a binomial times a binomial, so we can FOIL here. So we're going to do radical 2 times radical 5, that's radical 10. Radical 2 times negative radical 7, negative radical 14, plus radical 15, minus radical 21. Alright, you need to look back at this. Can we simplify any of these radicals? No, you cannot. So this is actually the final answer. Two more like that. we have 3 radical 5 times 2 radical 7. So we're going to FOIL again. So we multiply that times that, we get 6 radical 35, because 3 times 2 is 6, 5 times 7 is 35. I can only multiply regular numbers times regular numbers together and radicals times radicals together. Then 3 radical 5 times radical 2 would be a 3 radical 10. Negative 2 radical 3 times 2 radical 7 is negative 4 radical 21. Negative 2 radical 3 times radical 2 is a negative 2 radical 6. Look back at it, make sure everything's simplified. It is, so this is the correct answer. Alright, lastly we have radical 6 plus 4, radical 6 minus 4. What should pop out is that these are the same numbers, just 1 plus 1 minus. When that happens, if you FOIL, your middles will cancel out. Sort of like the difference of squares. So let's FOIL all of this out so you can see what I mean. Radical 6 times radical 6 is radical 36. Radical 6 times a negative 4 is negative 4 radical 6, because I can't multiply these numbers together because one is under the radical and one is not. 4 times radical 6 is positive 4 radical 6. And lastly, 4 times negative 4 is negative 16. Notice that the middles will cancel out because basically they're the opposite of each other. Negative 4 radical 6 plus 4 radical 6 cancels. We still have a little work to do because the square root of 36 is actually 6. And then we have minus 16. So the final answer is, let me put equal signs here so you know all of this stuff is goes with the previous line. 6 minus 6 is negative 10. So notice that for this particular problem, we started off with radicals, but we did not end with radicals. That's an important point for your next video.